Function operations. So we're going to look at adding, subtracting, multiplying, dividing functions. For question number 1, this is just a warm-up 1 and 2 right here. If we wanted to find g of 5, remember this is function notation, so you have to be given the rule, which is g of x equals x squared minus 5x plus 6. So to find g of 5, we know that's when x is equal to 5, so everywhere you have an x in this case, you're plugging in 5 and evaluating. So we get 25 minus 25 plus 6. So g of 5 is equal to 6. Looking over here, same thing, except for now we're not just plugging in a number, we have a variable and a number we're plugging in for this h of x for x. So we're doing h of c minus 2. So everywhere we have x, we're plugging in c minus 2 and adding that 7. So here, be careful, because remember that when you have a binomial squared, you need to write it out twice and FOIL. So first outside, inside last. So c squared, and then the outside minus 2c plus 4, because negative times negative is positive, plus 7. And then you're going to combine like terms, so c squared minus 4c plus 11. That's just review. But that's going to help us with the fact that we're doing function operations today. So you can add, subtract, multiply, and divide functions based on how you perform these operations for real numbers. One difference, however, is that you must consider the domain of each function. What makes a function not divine in the interval from -infinity to infinity, so all real numbers? So these are the things we're going to take a look at. So when you're finding the domain of a function, given the equation, there are 2 red flags that you're looking for, and we talked about this the other day. Variables that make the denominator equal to 0. Why? Because we can't divide by 0. And variables underneath an even root. Why? Because we cannot have a negative number underneath an even root, because remember that gives us imaginary solutions. So anytime you're looking at an equation, you are going to ask yourself these 2 questions here. Do you have any variables in the denominator? And do you have any variables underneath an even root? If the answer to both those questions is no, then your domain's all real numbers. If your answer is yes to either of these, then you have to look at finding the domain. So for question A here, we're given f of x equals 5x minus 4. So we're going to look at finding the domain. So do we have any of our red flags? Do we have any variables in the denominator? No. Do we have any variables underneath an even root? No. So that means this domain's easy to find. Means we can plug anything in for x, and so it's all real numbers. Looking at the second one, first, I would probably want to think about this in standard form. So if I FOIL this out, we would get first outside, inside last. So 3x squared minus 18x plus 5x minus 30. And this becomes 3x squared minus 13x minus 30. So that's our function in standard form. And so if I look at this function, there's no variables in the denominator, and there's no variables underneath an even root. Therefore, the domain is all real numbers, -infinity to infinity. Looking at this last one here, we have x squared plus 10 over x minus 3. And so for this, we know that this does have a red flag. It has the first one, which is variables in the denominator, not the second one. So we haven't talked about this yet, but remember we said that we can't have 0 in the denominator. So if you have variables in the denominator, you just basically take what's there and set it not equal to 0 and solve. So in this case, you get x is not equal to 3. So if we were to set up a number line, on my number line I would have 3 and it would be an open circle. And I can test any number on either side of 3 is to see if it works in this equation. And as long as it doesn't give me 0 in my denominator or a negative underneath an even root, then we're good. There is no even root, so we don't have to worry about that, so that makes it easy. So if I pick a number to the left of 3, such as x equals 2, and plug it in, we would get 2 squared plus 10 over 2 minus 3. So if I do that, 2 squared is 4 plus 10 is 14. 2 minus 3 is -1. So notice that does not give me 0 in my denominator. That's equal to -14, which is a real number. So all these numbers work. And let's do a number on this side. So if I do x equals a number to the right of 3, which is 4, so I'm going to plug 4 into my equation. So 4 squared plus 10 over 4 minus 3. 4 squared, remember, is 16, and 16 plus 10 is 26 over 4 minus 3, which is 1, so that's just equal to 26, which is also a real number. Doesn't give me 0 in my denominator, so therefore those work. So anytime this happens, the only number that's not going to work is whatever makes your denominator 0. So I didn't really need to make this number line, but I just wanted to show you. So I know the domain is going to be all real numbers except for that 3. So that's why I'm using parentheses, and that's it. And the reason we want to know these rules is because we're not going to have our calculator in order to look at the graphs, because of course you could always, if you had your graphing calculator in front of you, look at the graph and use that to help you. But when you get into upper level math, it's important to understand how functions work without having to plug it into your calculator. So now we're going to go ahead and look at function operations. We have addition of functions, and this is just a notation that you might see it written. Subtraction, multiplication. Sometimes multiplication doesn't have the x in front of it. You might just see f times g. And then we also have division. So f divided by g of x and f of x over g of x. Of course, g of x cannot be equal to 0. Sometimes you might also just see f divided by g. So again, that's dividing the functions. The domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. Also, the domain of the quotient function does not contain any x value for which g of x equals 0. So let's go ahead and do some practice. So for question number 6, we are given the two functions f of x and g of x. It wants us to find the two functions being added, subtracted, and the domain. So if we look here, first let's go ahead and look at each domain separately, and then we'll look at it when we add the functions together. For the first one, if I look at f of x, again, ask yourself those two questions. Do I have any variables in the denominator? No. Do I have any variables underneath an even root? No, so the domain's all real numbers. Same thing for g of x. So for this first one, we're going to go ahead and add those two functions together. So 2x squared plus 8, and then we're adding that to g of x, which is x minus 3. Notice I'm using parentheses around the functions as I'm adding them, because when you subtract, it's going to make a difference. In this case, when we're adding, it does not. So combine like terms. I don't have any like terms with the 2x squared or the x, but the 8 and the 3 are like terms. So when I add those together, I get plus 5. Or I guess I should say subtract 8 minus 3. So here is my functions added together. And again, same thing. You can look at both of them. Can tell the domain's all real numbers because it doesn't have any of those red flags. Now if I do f of x divided, or excuse me, minus g of x, when you have the minus there, don't forget to distribute the negative sign to both those terms. So 2x squared plus 8x minus x plus 3. Combine like terms, so 2x squared. And here we have, oops, I didn't mean to write 8x, just 8. So here we have like terms with the 8 and the 3, not the x, so minus x, and then 8 plus 3 is 11. And that's our new function. Again, no red flag, so negative infinity to infinity. So that's not too bad when you're doing addition subtraction. So let's go ahead and look at when we do multiplication division, which sometimes starts to get a little bit harder. So if I look at f of x again and g of x again, no red flags, and we already kind of, or no, we didn't. So no red flags, so all real numbers. And again, red flags, no variables in the denominator, no variables underneath the even roots. So for the first one, f times g is what we're doing. So f of x is 3x minus 5 times g of x. We have a binomial times a binomial, so we need to FOIL that out. First outside, inside last. So 9x squared plus 3x inside minus 15x minus 5. Combine your like terms. 9x squared minus 12x minus 5. And if we look at this new equation, f times g of x, notice there's no variables in the denominator or no, underneath an even root, so the domain is still all real numbers. Now we're doing f of x divided by g of x. And this does not simplify, so that means we want to figure out the domain. Now, I don't have any even roots, but I do have variable in the denominator, so I know 3x plus 1 cannot be equal to 0. So when I solve, 3x cannot be equal to negative 1, so x cannot be equal to negative 1/3. Any other number I plug in for x will work. The only number that makes the denominator equal to 0 is this negative 1/3. So again, if you draw a number line, we have negative 1/3 of my number line. It's an open circle. Every other number will work. So the domain is negative infinity to negative 1/3, parenthesis, union, parenthesis, negative 1/3 to infinity. And that's it for these functions. Let's go to the next page. So let's go ahead and do subtraction and division. So we have these two functions, and for the first one, f of x, there's no variables in denominator or underneath an even root, so the domain's all real numbers. Looking at g of x, now we do have an issue because we have that variable underneath an even root. So we talked about how to find the domain of this yesterday. And so how do we find the domain when we have a square root? Remember we said that we take that square root and what's underneath of it has to be greater than or equal to 0 because we can't have negatives underneath the radical. How do you get rid of that radical? You square both sides, and so 0 squared is just 0, and add 3. So x is greater than or equal to 3. So if you need to make a number line, you can. On my number line is 3. It's a closed circle. We have numbers greater than that, which goes to the right. So the domain would be bracket 3 to infinity. So when we subtract the two functions, 4x plus 5 minus root x minus 3, because this is underneath the radical, I cannot distribute that negative to these terms. And so none of these have like terms because remember, in order to have like terms with radicals, they have to have the same thing underneath the radical, which is called the radicand, and which these do not. So therefore, it does not simplify. It would stay like this. And so the domain of this entire thing, we can see there's that radical there. And again, this we said was all real numbers, but this is the area with the radical that we're concerned about. So the domain is 3 to infinity. So now let's go ahead and divide the two functions, 4x plus 5 divided by root x minus 3. Now we have two parts that are red flags. We have a variable in the denominator, and we have a variable underneath that even root. And so when this happens, because we can't have 0 in the denominator, instead of doing what we did over here, which was set it greater than or equal to 0, we actually take what's in our denominator, the root x minus 3, and just set it greater than 0, because now we can't be equal to, because it would make my denominator 0. We can't divide by 0. So again, I would square both sides to get rid of that radical. So that gives us x minus 3 is greater than 0. Add the 3, so x is greater than 3. And again, if you need to make a number line, you can, but the only difference from before is just that instead of the bracket, we're not including the 3, so it would just be 3 to infinity. So for these parts, why don't you go ahead and pause the video and practice on your own. When you're done, you can unpause and then check your work. All right, so let's do this first part. So f of x is this function here. And we're going to go ahead and write the domain. There's no red flag, so the domain's all real numbers. Then we have g of x, and the domain of this, no red flag, so it's all real numbers. And then for the last one, we have h of x, which does have a red flag because of that radical. So we're going to go ahead and solve. So root 2x minus 5 has to be greater than or equal to 0 because it's not in my denominator. Square both sides to get rid of that radical. And then add the 5. Divide both sides by 2. And so the domain is going to be, and if you need to make a number line, you can. Here's 5 halves. It's closed circle. We want numbers greater than that, which goes to the right. So bracket 5 halves to infinity. So now let's go ahead and look at question 9 and do the operations. So we're going to do the operations and find the domain. So f plus 2 times g of x. So in this case, we have f, which is 4x minus 1, and we're adding that to, and that 2 is being multiplied by the function of g of x, so that's why we're going to put it on the outside, and g of x, which is 2x squared plus 3. So now we're going to go ahead and solve. In order to solve this, you want to distribute and then combine like terms. So 4x minus 1 plus 4x squared plus 6, and then combine your like terms. So 4x squared, and then the 4x doesn't have like term either, so plus 4x. The only like terms we have are the negative 1 and the 6, so plus 5. And since both these functions originally were domain all real numbers, and you look at your answer, whoops, I forgot the x there, we can see that the domain of this, because there's no red flags, is negative infinity to infinity. Looking at the next one, we have g minus h. So we're subtracting the g minus the h function. And when I do that, none of these have like terms. I can't distribute the negative underneath in the radical because there's a radical there. So that is as simplified as we get to x squared plus 3 minus root 2x minus 5. And the domain, because of that radical, is going to be using the domain of h of x. So the domain is bracket 5 halves to infinity. So now I'm doing f of x times g of x. So that means I want to FOIL because we have binomial times a binomial. So that gives us 8x cubed because 4 times 2 is 8, and x times x squared, you add the exponent, so x cubed. And then 4x times 3 is 12x minus 2x squared, and then minus the 3. And so when you write this in standard form, 8x cubed minus 2x squared plus 12x minus 3 is our answer. There's no variables in the denominator or underneath an even root, so no red flags, which means the domain is all real numbers. Looking at question 12. So for question 12, we have h squared, so root 2x minus 5 squared times f of x, which is 4x minus 1. When we square something with the radical, it gets rid of it. So this is 2x minus 5 times the binomial 4x minus 1. So we need to FOIL this out because it's a binomial times a binomial. Remember, binomial just means two terms. So that gives us 8x squared minus 2x minus 20x plus 5. So 8x squared minus 22x plus 5. And then you have to be careful. So for this problem, you always want to look at the entire problem that you did in order to find the domain. In the original problem, when we started, we had a radical, but when we squared it, it went away. However, because you still have a radical in the equation, that means that you still can't have numbers that make underneath this radical negative. So this domain that we're using for this answer is still going to be bracket 5 halves to infinity because of that radical. So again, even though it disappears in the answer, it's still a domain restriction because we did have a radical in the equation. So the next one we have the two functions being divided, f divided by g of x. So 4x minus 1 over 2x cubed plus 3. So we have the issue with the variable in the denominator. So remember when that happens, we take what's in our denominator, 2x cubed plus 3, and set it not equal to 0. Because it's not a radical, we don't do the greater than or equal to, or I should say not an even root. So when I solve 2x cubed not equal to negative 3, because you're going to subtract the 3 to the other side. Remember, you're doing PEMDAS backwards when you solve for the variable. Divide by that 2, so x cubed is not equal to negative 3 halves. How do you get rid of something cubed? You take the cube root of both sides, and so you get x is not equal to the cube root of negative 3 halves. And you know what? Let's go back a second. I don't know why I put cubed there. It should have been 2x squared. I don't know where I got the cubed from because of the plus 3. So this would be taking the square root. Remember, when you get rid of even powers, you need plus or minus the square root. So plus or minus the square root of negative 3 halves. Oh, wait a minute. We have a negative underneath the radical here when we're solving. Can't have the negative under even roots because it's imaginary. That means because we get imaginary numbers, no matter what we plug in for this x up here, nothing's going to make our denominator 0. And if you think about that, if I plug in a negative number and square it, it's always going to be positive, and then we're multiplying it by 2 and adding 3. So again, we can't get 0, therefore the domain of this is all real numbers. So even though there is a variable in the denominator, it doesn't necessarily mean that we're going to get something that does make our denominator 0. And we can look at the graph just to show that. So I plugged it into my y equals. Notice I use parentheses around what's in the numerator and denominator. And if I hit graph, and I'm going to do zoom 6 for a standard window. So I graphed it, and then I zoomed in right here just so you can see that there is no 0 on my graph. So nothing's going to make that equal to 0. And so even if you look at 0, when you plug it in, you get negative 0.3 because again, what are you doing to your equation? You're doing 0 squared times 2 plus 3. So that's why the domain's all real numbers. And then for 14, we're dividing the functions. We have g of x divided by h of x. So for this, this is not simplified because remember, we don't like to have radicals in our denominator. So when that happens, remember you need to rationalize it. So how do I rationalize this? I'm going to multiply it by what is going to make this a group of 2. So that means I need to multiply it by root 2x minus 5. Oops. Because if I multiply that out in my numerator, I get 2x squared plus 3 times the square root of 2x minus 5. I can't multiply this underneath because there's not a radical to multiply. And then down here, because these are both underneath the radical, I can multiply those underneath. So I'm doing 2x minus 5, and I have 2 of them, so it's squared. So that cancels out the radical, which we did on purpose. So we have 2x squared plus 3 times root 2x minus 5 divided by 2x minus 5. And so that would be my simplified answer. And then, of course, the domain, we can't have, and if you look back at this problem up here, we can't have variables in the denominator or underneath even roots. So we're going to take what's underneath there from the start and set it greater than 0, not equal to, because it can't be equal to in the denominator because we can't divide by 0. So square both sides to get rid of that radical. And then add the 5 divided by 2. So x is greater than 5 halves. So your domain would be parenthesis 5 halves to infinity. So I went ahead and graphed this just to show you. So this would be 5 halves right here to infinity. Of course, I can't just plug in 5 halves. If I try to plug in 5 halves, I know it's going to be error. It's not equal to that. So notice it doesn't give me anything for my y equals. But let's say we plugged in something right above that, so 2.6. Notice we get 36.93, so 5 halves to infinity. So that's just to graphically show you that that's the domain, even though we want to make sure we can do this without our graphing calculator. And that's it for finding or doing function operations and finding the domain.